Yes, I'm Erik, and I'm going to share some of my independent research on various space industries. A bit about myself: I studied physics, and then I was part of the team developing the first satellite of Estonia, SQ-1. Then I operated it in space, took a beautiful image of cloudless Estonia and Latvia. Then I worked in Scotland and Canada as a space system engineer, have over 15 satellites in space, and have also explored some space startups. But in parallel, as a hobby, I'm also curating 3 large and leading space databases now: NanoSats covering nanosatellites for over 10 years, NewSpace Index covering small launchers and constellations, and Factories in Space covering emerging and future themes. So why is space so important to me? I really believe that humankind settling space will help to solve some of the biggest problems down here also. It will create the technologies, and then it will change us through overview effect and by having common positive goals. For example, if we figure out a way for abundant, cheap, green energy, it would make carbon capture, vertical farming, and ocean desalination economically viable everywhere right away. Or we could move most heavy polluting manufacturing into space, because in space there is no life to harm, so the word pollution gets a different definition, which would really decrease the environmental impact of manufacturing on Earth. But for all of that to happen, we need new economic drivers for spaceflight. We need new reasons to go to space, new revenue sources. This is the missing piece to speed up development, because government budgets will not increase that much. Comparing to the gold rush, not many picks and shovels will be sold until we actually find that gold in space, also known as the killer app. Profit does enable a lot of R&D. So let's look at how some space industries are actually doing then, starting with nanosatellites. So here we have the running total of satellites broadly under 10 kilograms. The growth really took off around 2013, and now there are over 2,500 nanosatellites in space. But their total mass is only about 10,000 kilograms, so in a way they would all fit on a single large rocket. Here we have yearly launches together with organization types. So for example, in yellow we have universities that were initially the most popular, but then companies took over in blue around 2014, but they do have quite a lot of variation also. And as a map, 85 countries have nanosatellites now. United States is far ahead with over 1,500. Africa and Central America are quite empty. And Latvia, of course, has Venta-1 launched in 2017. So moving on to NewSpace Index, and first focusing on satellite constellations, there are over 370 in my database. And here they are by applications. So Internet of Things, IoT, is the most popular, but there are also many notable bankruptcies already, and many of them are now pivoting to direct-to-cell phone connectivity. Next up is Internet from space and various types of Earth observation. Here we have constellation company founding years. As you can see, major peak and jump in 2015. That coincides very well with other new space trends, actually. So Falcon 9 reusability tests, Skybox sale to Google in 2014, Planet and Spire launching first batches of satellites. But many constellations have also already failed or are still in that experimental prototyping phase. Most of them will never reach that operational status because, as it turns out, the unit economics of satellite constellations is extremely challenging. It's very hard to make a satellite profitable. Moving on to small rockets, 210 in the database, and here we have their founding years. So similarly, in 2014, we had major jump, peak hype years that lasted up to 2020, 21, until some companies went public and one went bankrupt and one is close to it, but some new ones still being created. And then, but most of them have not made it to the launch pad. So here we have yearly first orbital launch attempt years. Only few maximum. Many already retired after a launch or two, and lots of delays. And it turns out here that the market can probably support for only a few in the Western world, purely commercially. So whoever is still alive and large enough, they're moving to larger rockets. Finally, Factories in Space, so covering the emerging in-space economy and in-space manufacturing themes. And if you ask, what is in-space economy? It's basically all this. It's the new extraterrestrial space industries. It usually means generating revenue in space. So here the vision is to have bustling multidisciplinary activities all across the solar system, near Earth or Moon or Mars, near asteroids, to have orbiter factories that would combine space manufacturing, space solar power, in situ resource utilization. And this database has over 900 entries. The most popular is in-space manufacturing, but there are no active ones there yet, followed by space utilities and in-space transportation. So now let's go back to the big picture view for a bit and talk more about some challenges and mental models. So first off, we heard many times this recent study that space economy is a $600 billion industry, growing to 1.8 trillion in just over 10 years. But it's not true. Most of that is not space. It's GPS chips in phones, etc. So not real. The real space of building satellites, launching them, telecommunications, Earth observation, these are approximately tens of billions each. And only some of those are economically sustainable. So some have revenue, but profit is extremely rare, especially in NewSpace. So we need better studies to understand how real space industries are doing, so we can take the proper actions to grow them also. There is also a big chicken and egg problem in NewSpace. So for example, even if, as an asteroid mining company, even if you can raise billions to make it happen at scale, where are the customers? They will likely take years to emerge, especially in space. But without those raw resources and customers, the supply chains also don't develop, so very, very hard to make it work. And it's important to keep in mind that new markets usually grow very, very slowly. Thus, it means that we need more gradual approaches. We need approaches involving existing large markets that could be serviced from space in better ways. Starlink is a great example of that. We think it might be electricity, computing, and in-space manufacturing for Earth also. So one way past the chicken and egg problem is looking at the hype. So here we have the Gartner hype cycle methodology populated with space industries. So the color shows the time to get to the plateau where company is financially viable. For many, it will be very long, 10, 20 years. For many, the hype hasn't even started yet. So the point I wanted to make here is that in NewSpace, most people and investors are influenced by the amount of companies, their funding, the news about them, but it's very rarely market demand-based and only sometimes correlated to the theoretical market opportunity, meaning their hype and a lot of wishful thinking also. So we need more people and investors working on things that could actually be big. Another way we could look at these market timelines and market sizes. So horizontally, we have existing nearby markets to distant markets and small to large markets. So as an example, space solar power. Electricity is a huge market now already. Yes, making energy from space happen is very challenging, but at least a huge, almost endless market will be there. If you take in-space construction, it's easy to imagine that it will be a huge industry in the future, but probably quite distant future. So a great question to ask is, if your thing is ready tomorrow, how many customers would you really have? For a lot of NewSpace stuff, not many or none. So it's important, so can't make a big business with small or non-existing markets. There is nowhere to make revenue from. Final thoughts. In ancient times, we had Silk Road, and then we had spice trade. So coffee and tea, these are mostly luxury and novelty products. They are not needed for human survival. Some people might disagree. But they did largely kickstart the world economy hundreds of years ago. So perhaps an ethical version of spice trade will happen for space, in space. Space wine, space diamonds. Not everyone likes that idea, but these are very large industries. So this was just the tip of the iceberg. Please see the websites for much more content, and thank you.
Erik, thank you so much for a very realistic presentation, as well as raising some challenging questions. There is one question that we will very quickly address. What is your thought about space pollution, unused satellites and pieces of satellites circulating around the Earth?
It's definitely a problem. It's getting better, but it does have a bit of hype component also that it's very easy to be angry about or emotional about. But the challenge with space debris is that no one is willing to pay for the active removal of it. So if it would be a real problem, I think more governments would be willing to actually pay for it also. So, yeah.
Thank you. Thank you, Erik, so much for your presentation and being with us today.